Evening, everyone. And this is the first class of the Foundations of Logic course. And it's an experiment because we have never done this online before. Just a minute, let me see that the recording is on. I just have to check that the recording is on. Yes, it is. Okay. So it's going to be quite different than normally because we don't have the usual personal interaction. We have interaction in this online way, which is not the same thing, but we'll try to make it work. So I hope you can all see the screen, the shared screen, with where I have some slides. And I will now, okay, so here is the first slide. This is a rough description of what we're going to do. So the first 2 weeks, we're giving background in the syntax, semantics, and predicate logic, or first order logic. So FOL, FOL, here means first order logic. The third week, we'll talk about completeness. The fourth week, we'll do some model theory, and the remaining time, we'll talk about Gödel's incompleteness theorem and about decidability and undecidability. Well, here are the teachers. Me, I'm Dag Westerståhl. Normally, I would be at Tsinghua as a genuine professor right now, but I'm here in Stockholm. And you also have Jia Liang, our teaching assistant. So a few words about what you need, the material you need for this course. There are these lectures with the slides, and if all goes well, you'll be able to you'll be able to see the seminars or webinars afterwards, and also see the slides. If there's a problem with that, you can probably also, I can just also send you the slides, but we'll see about that later. Then there is a textbook, which I suppose you have. We're not going to read all, but a lot, and you will see exactly what is included. And then last but not least is the homework, which is very important in a course like this, because you cannot learn logic just by reading a book. You have to do it. You have to do it yourself, and the only way to learn it really is to do exercises and do the homework. As I said, there are slides, but not everything is written on the slides. On the other hand, it would be very boring if I just showed you slides and talked. So to make it more dynamic, the idea is I will write some things by hand using the slides or parts of the slides as a whiteboard. And I will always have some empty slides available so that we can, if there are questions and I need to answer them by writing, I can do that. But I will not talk about everything. Some things you will have to read for yourselves in the book. You will get more information about the homework, but in principle, it's one piece of homework every week that you should send to Jia Liang as PDF files, and then they will be corrected and graded as usual. The homework is important not just for learning, it's also part of the examination. So you should spend time doing the homework. And everything in the homework should be written in English. Well, because that's the official language of this course. Now, how do we communicate? Well, this is a one-way communication in the sense that I speak, I'm write on the blackboard or whiteboard, etc. Your possibility to participate is to ask questions. There should be a raise hand button, and then when I see that, I can unmute your microphone and you can speak your question. Another possibility is to use the chat or the question and answer Q&A facility. But of course, there may be questions that take longer time and that you need to ask outside of class. Then you can use the WeChat group. If you have questions that you think are of general interest to others, please ask questions via the WeChat group. And then we will answer either through that group or by email. Finally, you can also send just an email to me or to Jalan with questions. But concerning the questions during the class, I suggest that you raise your hand as soon as there is anything you don't understand, or you want me to, or there is some problem with the communication or anything, because for me it's much better to understand that there is an audience out there that actually listens to what I'm saying, but also understand what I'm saying. In a normal classroom, I can see that by looking at the students, but now I cannot do that. So I need, from time to time, some reactions from you. That will make everything much better, and that will make me feel that I'm actually talking to you, or talking to someone. Okay, so these are, you should attend the lectures. Now, in this course, it usually happens in the beginning that some people realize that the course is not exactly what they wanted. Maybe it's too difficult or too technical or too easy, or I don't know, and you want to drop it, and that's fine. But if you do, please tell us so. You can get a good idea of the level of the course, I think, after this first week, or at least the first 2 weeks. So let me, before we really begin, let me say something about what will happen later when we have done these first 2 weeks of introduction. So the third week is completeness. So what is that about? Well, logic is about consequence. It's about conclusions following logically from premises or from assumptions. But what does that mean, that they follow logically? Well, there are 2 ways to explain that. One is the sort of natural, intuitive way, which says that if the premises are true, then the conclusion must be true. That's a semantic explanation in terms of truth. The other way to explain consequence is in terms of rules. So you lay down some simple, basic rules of inference, and then you see that all your reasoning is done according to these rules. So you can see these are 2 completely different ways of thinking about consequence, but the completeness theorem says that they are equivalent, at least for first order logic, which we'll study here. That's not a trivial result. It's an interesting result, and we'll spend some time showing that this is the case. When we have done that, we will have some insight into methods of dealing with the language and with models of the language, and that gives us the opportunity to give a glimpse of the field of logic, which is called model theory. This is about the expressive power of first order logic, what you can say and what you cannot say in that language. So for example, you can say that there is a certain fixed number of things with a certain property, maybe 27 things that have a certain property, but you cannot say, and that is something we will show, that there are infinitely many things, or that there are finitely many things with a certain property. So this is a limitation of the expressive power, but we'll actually see that this is a weakness in a sense, but it's also a good thing. It's also part of the strength of this language. By the way, as I said, if there are questions, raise your hands. There might be also questions like you're speaking too fast, or I don't hear what you say, and things like that. Just any kind of questions, just raise your hand. Okay? Okay, I will go on. Okay, so the final big part of the course is about incompleteness. And this is about theories which attempt to prove true facts about some objects like numbers or electrons or whatever it is the theory is about. So if you formalize a theory, you can use a language like first order logic, you can state the axioms, and then you can see what you can derive in this theory. And that's basically the way we know things. For example, how do I know that there are infinitely many prime numbers? So a prime number is a number that cannot be divided by any other number besides 1 and itself. So those are the prime numbers. But how many are there? Well, for every number, there is a larger prime number. So there are infinitely many. But how do I know this? Well, there is a proof. Actually, Euclid gave a proof 2,400 years ago. That proof can be formalized in a theory, and that's the fact that this proof exists is how I know it. So I know that it's true because it's proved from axioms which I also know are true. So that may raise a possibility that, well, okay, maybe I can prove all true facts about certain objects like numbers. Now that's what the incompleteness theorem says. No, you cannot, because it says that if you have any axiomatic theory which is consistent, no contradictions, and if it contains some very elementary arithmetic, then it's incomplete. Incomplete entails that there are true sentences which cannot be proved. And this is essential, this is a characteristic. You cannot help the situation by adding these true sentences as axioms, because then there will be other true sentences which cannot be proved. So this is a very deep and interesting result, and we'll spend a lot of time showing that this is true. Finally, we'll talk a little bit about undecidability. So a problem can be decidable. That means that there is some mechanical effective method that answers questions about the problem. So again, problem 1, is n a prime number? Well, that's decidable because you just start dividing n by all the smaller numbers, and if one of the divisions work, then it's not a prime number. Otherwise it is. So that's decidable. It can take a very long time, but after a finite number of steps, you get the answer. But here's another question. Does this sentence follow logically from some premises? That's the decision problem of first-order logic. And it's all one of the basic observations in logic that this is undecidable, which means that there is no method. It's not that we haven't found a method to give a yes or no answer to this question. There is no such method. And that's, of course, also a conceptually very interesting fact, and we'll end the course by talking about that. Okay, so that was just a glimpse of some good things to come, but this week we'll start with the syntax and semantics of first-order logic or predicate logic. Some of you may know all this before. In this case, these first 2 weeks will be very easy for you, but that's fine. Because in any way, we need to establish terminology and notation that I will be using all the time, and they can differ from textbook to textbook. So it's good to follow these lectures anyway. And if you have not seen it, or if you need to rehearse it or remind yourselves of how this language works, then this is exactly what we'll do. But we're going rather fast, so I am presupposing that you have actually seen first-order logic or predicate logic in some form before. Anyway, as I've said many times already, if there's something you don't understand or something strange going on, then raise your hand. Okay. So the first thing you will see is a lot of Greek letters, because we're going to use Greek letters for formulas. And now I will try to write them actually here. Okay, so for formulas, we're using these letters. So the first one is phi, the Greek letter phi. It's also sometimes written like this, but I prefer this notation here to the left. The second one is psi. The third one is chi. Maybe it's not written so clearly. Let me try again here. Something like that. And the last one is theta. So these are not actual formulas. They are meta variables that we're going to use to talk about formulas. So I say, let phi be a formula such that blah, blah. I'm also going to talk about sets of formulas. And for these, we use some capital Greek letters, like this one, or this one, or this one. So this one is gamma. This one is sigma. This one is delta. So you will see these letters all the time in this course. Okay, so today